In this session, we study the main sequence stars. We make a hypothesis. The main sequence stars bond hydrogen at the centers. We start with the stellar equations using the dimensional analysis and discover the luminosity is proportional to the m cubed and the radius is proportional to m to the power index is n minus 1 over n plus 3. So by combining these twos, you can substitute this m into the here. And the radius is expressed with the luminosity using this equation. And the luminosity is expressed 4 pi r square sigma t to the fourth Stefan-Boltzmann equation. So these are substitute here. Then you can find the luminosity is expressed with the temperature and the luminosity. So luminosity appears in the left hand side and right hand side. Then we combine these luminosities. Then luminosity is related with the temperature, surface temperature of the stars. And then if you take a log L is proportional to the log T. And the proportional constant. Actually, the slope corresponds to these quantities. So in the case of the CNO cycle, N is 16th. This slope can be calculated. It becomes 8.4. In the case of the PP chains, N is equal to the 4. Slope becomes 5.6. If you remember the HR diagrams of the open clusters, we have two slopes. These two slopes. Higher slope is correspond to the CNO cycle. And the shallow slope corresponds to the PP chains. So we can explain two slopes of the main sequence stars. So I have explained luminosity is proportional to the m cubes. Then duration of the main sequence star can be estimated. Mass divided by luminosities. So duration of the main sequence star is proportional to m to the minus second. So massive stars spend a shorter time on the main sequence. This explains why in an ensemble of stars born at the same time, like a star clusters, open cluster, globular clusters, the more massive stars leave the main sequence earlier. So massive stars correspond to the high luminosities. So this is massive stars. And leave the main sequence earlier. So massive stars is leaving and less massive star is leaving. Yeah, this is we find out change of the HR diagrams depending on the age of the star clusters. So if you look at the HR diagrams of the globular clusters, we can understand age of the globular cluster is older than the age of the open clusters because this is not a main sequence. Main sequence star is this nearly the straight lines, but some of the heavy stars has already left the main sequence stars. Then we'd like to also estimate the minimum mass of our stars. So from the dimensional analysis, temperature is related to m over r, and the radius is proportional to the m to the n minus 1 over n plus 3. So you can substitute this r into the here. And the temperature is expressed these equations. So in the case of the PP chains, n equal 4. So you can substitute n equal 4 is a Tc. Central temperature of a star is expressed m to the 4 over 7. Use the reference of our suns. Central temperature of the suns and the mass of the suns is divided. So we don't have to use a proportional constant. Minimum temperature of the central point in a star should be larger than the 4 million kelvins. Then we could find the minimum mass of the stars. This is 4 million kelvins. And the central temperature of our sun is 15 million kelvins. And we could estimate the minimum mass of the star is 10% of our solar mass. And also we could estimate the minimum luminosities of the main sequence stars. So because the luminosity is proportional to the m cubes, we use this equation. Minimum luminosity over the solar luminosity is equal to the minimum mass over the solar mass. Then minimum luminosity becomes 10 to minus 3s. So if you draw the HR diagrams, log L divided by the solar luminosity vertical line, and the horizontal line is log T. Main sequence star appears here. Luminosity of the star is 10 to minus 3s, so it appears 10 to minus 3s. This is correspond to the lowest luminosities. Okay, this is the end of this session.